Hi, Chem12. So I'll go over those couple of questions first, and then we'll start looking at new material, which will be on balancing half reactions. So this was number two. So it described a reaction where you've got cesium plus chlorine gas uh, forming cesium chloride. So there's the reaction. They kind of give you all the materials, and you just have to balance it. So the way you go about figuring out what is being oxidized and what is being reduced is by looking at the oxidation number. So because cesium is in the elemental form here, that's going to be a 0. And then cesium here is going to be plus 1. So that's going to be an oxidation, right? So you're going from 0 to plus. That means in order to gain a positive charge, you have to get rid of an electron, right? So there would actually be an electron over here. Okay, and then the Cl2 going to chlorine ion, same idea. You're going from 0 to -1, so you're going to gain an electron. So this will be your reduction. Okay, so the electron, um, if I wanted to balance this half reaction, I'd put a 2 there, and then there'd be 2 electrons over here. Okay, so that'd be your reduction. And remember, whatever is being oxidized, that's the reducing agent, and whatever is being reduced, that's the oxidizing agent. So cesium is the reducing agent, and chlorine gas is the oxidizing agent. 5 is similar. You're trying to determine if it's a redox reaction. So again, in order for a reaction to be considered redox, you need to show that both these processes are occurring, oxidation and reduction. If only one is going or neither is going, it's not a redox reaction. So what you do is, here's your reaction. And so let's start with the iron. Okay, so iron here is in the elemental form, so that'll be 0 oxidation number. And here's the sulfate, which altogether carries a 2 minus charge. And so Fe is going to be 2 plus. So because we're going from 0 to 2 plus, this is going to be oxidation. Okay, so again, the oxidation means loss of electrons. And then here, you've got hydrogen, which is going to be plus 1. And then hydrogen over here is going to be 0. And so you're going from plus 1 to negative to 0. So that's going to be a reduction. So because you have oxidation and reduction occurring here, then we say this is a redox reaction. So how would you know if it wasn't occurring? Like, let's say iron was plus 2 over here, and it was plus 2 over here, right? So say it was in some compound form, then it never changed, therefore it's not being oxidized or reduced. Or if you look at a reaction where two things are being oxidized, same idea, right? So again, in order for it to be a redox reaction, you have to show one of the elements is being oxidized and another is being reduced. Okay. All right. So what we're going to get into today is going to be the balancing half reactions. Okay, and so this is called the half reaction method. And we'll use this to balance full reactions. Okay, so right now we're just going to balance half reactions. So we'll get to balancing full reactions, and we'll use the half reaction method to balance full reactions, and then we'll use the oxidation number method to balance full reactions. Okay, so again, this is a lot different to what you're used to with balancing chemical reactions. Okay, so let's go through the steps. Now, when you get these type of questions where they ask you to balance, these are the ones that aren't going to be in the back table. Okay, so remember you have a table of half reactions. So when you get questions on this type of stuff, these aren't going to be on there. So you have to use this method. Now, some of the reactions are going to be in acidic conditions, and some are going to be in basic conditions. And we'll talk about that a little bit more when we start looking at actual batteries. Okay, so let's start with this one here. Okay, so you got RuO2 going to Ru. And so how we know it's acidic or basic is either you'll see something that's obvious, it's an acid, or it'll be like this where they just indicate beside the reaction what type of conditions that's placed in. So this is in acidic conditions. Okay, so the first thing you'd want to do is you want to balance all the major elements, so everything other than oxygen and hydrogen. So in this case, that would be the Ru. So they're already balanced. Okay, so I'll just go through this step by step. So they're already balanced, so we got the same thing. The next step 2 is we want to balance the oxygen, and the way we balance the oxygen is by adding water. Okay, so we have two O's here, which means we have to have two H2O's on this side. Okay, so now you've got two H2O's. Okay, so oxygens are balanced. Okay, step 3, you balance the hydrogen atom by adding H plus. Okay, and then the reason why it's H plus is again because you're in acidic conditions. Okay, so you've got 2 times 2 here, so you got 4 hydrogens, so you have to have 4 H pluses on this side. Okay, so now we have this reaction. Okay, so remember, when you're balancing a reaction, as it says on the top here, you balance according to mass, which is the way we've been used to balancing reactions. So that's like the conservation of mass. And then now we also have to look at charge. Okay, and so here you've got 4 plus. So in order to balance that out, we have to add electrons. So remember, we can only add electrons. So you've both this side on the right here is a 0 charge, and so we need to get the side on the left a 0 charge. So we add 4 electrons. Okay, and so now it's balanced. Okay, so this is your complete balanced half reaction. So when you want to assess it, just look at the atoms first. So like Ru is 1 here, there's 1 here. You've got 2 O's and you've got 2 O's, and you've got 4 H's and 4 H's. So you look at the elements first and then look at the charge, right? So you have 0 on this side, you have plus 4, minus 4, you have 0 on that side as well. Okay. So now what I've done here, you can do a lot faster. Okay, so you can kind of do this, like today's questions, they're all going to be on these type of balancing questions. So you don't have to write it out 4 different times. You should be able to do this a little bit quicker than I did here, right? But I just wanted to show you the different steps that we're going through. Okay, let's look at example 2. So again, here it tells you it's in acidic conditions. Okay, so first thing is run it through that same list. The major atoms here are sulfur. So you have 2 on this side, we have 1 on this side. So we'll put a 2 in front of the HSO4 minus. Okay, so next is going to be the oxygen. You have 8 here. You already have 8 here, so there's no need to add water. And then you look at the hydrogen, you have 2 here, so we have to add 2 H pluses on the left. Okay, so we add 2 H pluses on the left. There's a 2 here, so there's a minus 2 charge on the right, and then you've got negative 2 and positive 2, so that's 0. So you want this side to be negative 2, so we have to add the 2 electrons on this side. Okay, and so this is the balanced half reaction. Okay, so that's how we balance half reactions when they are in acidic environments. Okay, so the next thing let's look at is how do we go about balancing in basic environments. Okay, so you have to sort of have an extra step. Okay, so let's start with this one here. Okay, so let's just balance it the way we normally would. Okay, so major atoms, there aren't any here, so you got 2 O's, 2 O's. So you don't need to add water. You have 1 H, so we add an H plus on the right. And then we look at the charge, the side's negative 1. And so to get the side negative 1, we add 2 electrons. Okay, so this is where we'd end up right here if it were acidic. So now how do we account for it being basic? Well, if it's basic, the H plus isn't there. So the way you do this is you look at how many OHs you have, how many H pluses you have, and what you do is you add OH, that many OHs to both sides. So it's kind of like math. If you do something to one side of the equal sign, you have to do it to the other side. So we add OH to both sides. And so now what's the H plus and the OH minus going to want to do? When you have H plus and OH minus, that's H2O, that's water. So that just becomes water, which is right here, and then the OH minus is right there. Okay, and so now this is your half reaction balanced for basic conditions. And just if you don't know what I'm talking about as far as half reaction goes, half reaction is just that. It's half the overall redox reaction. So it's a reaction that's either showing reduction or it's showing oxidation. Okay, it's one half of a redox reaction. Okay, and so again, you can go through this and check to see it's all correct. Okay, one more here. So chlorine gas is oxidized to ClO3 in basic solution. Okay, so this is what we're starting with. Okay, so that's kind of like our skeleton reaction. So first thing, again, we can treat this as if it were acidic, and go through all the steps, and then we'll account for the fact that it's basic at the end. So major atoms first. So you've got 2 chlorines here. You have to add 2 chlorines here. Okay, and so there's your 2 multiplication of 2. So now you've got 6 oxygens. So in order to balance the 6 oxygens, we add the 6 waters, and then that gives us 12 hydrogens. So that's where we add the 12 H pluses. And then if you look at the charge on the left is 0, and then the charge here is -2, +12. So we need another -10. So we add 10 electrons. Okay, so this is where we would leave it if it were acidic. So now what we have to do is, because we have 12 H pluses, we have to add 12 OH minuses to both sides. Okay, so we add 12 OH minuses to both sides. Again, this is going to react to produce 12 waters. Okay, so now you're left with this here. So you've already got the 6 waters over here, and now we've got 12 waters over here. So you have 6 and 12, so you can get rid of the 6 waters here, and you can change that 12 into 6. Okay, and so what you end up with then is this reaction. Okay, so Cl2 12OH minus going to 2ClO3 minus plus 6 waters. Okay, so 6 because we canceled out 6 waters on both sides, and then your 10 electrons. Okay, half reactions should always include electrons. Okay, so that's part of the oxidation reduction that's occurring, right? So here you're losing 10 electrons, which is why it's an oxidation. Okay, so today's, what I want you to do is page 203, number 19. So all this question is balancing half reactions. So there's a bunch of half reactions on that question. And so again, for Wednesday's class then, ahead of that, let me know if any of these you were unable to balance, right? Check in the back of the book. And if you were unable to balance it, just let me know, and I'll do that one at the beginning of the lesson. Okay, so work on that for Wednesday. So again, just to reemphasize, Monday, school begins. Again, use that time if you're struggling or need some extra help. Just come in and get that. I'm not, like I said, I'm not teaching any new material, so you're not going to be missing anything. It's just an opportunity for you to get extra help if you need it. If things are fine in terms of how you're handling the online learning, then there's no need to come in. Some of you have been asking about the marks. So the last marks I gave you was where we were at right before spring break. So that was on your interim. And so now this week I'll basically take all the things that you've done after spring break and include that and combine that with the mark that you had before spring break. Okay, so you'll have an updated mark by the end of the week this week. Okay, so just give me a couple of days to get that done, and then you can just send me a message to find out what your present day mark is at. Okay, so again, at the end of this unit, I'll give you a take-home exam on electrochemistry, redox chemistry, and that'll be the final piece of assessment that I put into the marks. Okay, so we're getting there. Still have a few more topics to cover, but we'll get through the entirety of the course before the 3 weeks are basically the last 3 weeks of the semester. Okay, so again, just keep sending me questions if you have them. Okay, so I'll stop here. Again, continue to be safe, and I'll talk to you again on Wednesday. Okay, bye now.